Okay, in lesson 30, we extended what we learned in lesson 29, where we were dividing unit decimals. Now today we're going to be using that knowledge we learned yesterday in order to divide non-unit decimals. Now when we're talking about non-unit decimals, we're actually talking about decimals that are not just like 1/10 or 1/100th or 1/1000th. So in this case, we have in A, we have 2 4/10, and that should have been 2 4/10 on top, divided by 8/10. And we're going to multiply both these by 10 in order to get rid of the decimal, because the decimal is going to shift one place to the right, and we're going to end up with 24/8. Now, 24 divided by 8, sometimes it's easier for people to think what times 8 is 24, and that would be 3. On B, we're going to end up with 2.4 over 8/100. Now, we can see we want the 8/100 to move two place values. So we're going to have to multiply both of them by 100. So we have 2.4 times 100 and 0.08. So when I move two place values on the 2 4/10, it's going to make it 240. And then 8. And if I go ahead and disregard the 0 here, I know 8 will go into 24 3 times. So 8 times 3 is 24. So 30 times 8 would be 240. On D, now we're going to rewrite it as a fraction, 0 48/100 over 6/100. And we're going to multiply both of them by 100 to move them two place values. So we're going to end up with 48 over 6. And I know 6 times 8 is 48. On E, we're going to rewrite it as a fraction, 8 4/10 and 7/10 times, we only want to move 1, so we're going to multiply by 10. So it'll be 84 divided by 7. Now, I know that 7 times 10 would be 70. 7 times 11 would be 77. So 7 times 12 would be 84. Now, a lot of times it's best to use a benchmark fraction when you know, like tens, and then move up. If not, you have to do the standard algorithm for long division. Next, we have 84/100 divided by 7/100, and we're going to multiply that by 100 because we want to move it two place values, and that's going to be 84 over 7. And once again, I know that 7 times 10 is 70, 7 times 11 is 77, so 7 times 12 would be 84. Now I have 4 5/10 over 1 5/10. Multiply both by 10, and I'm going to get 45 over 15. And I know 15 times 3 would give me 45. 45/100 over 15/100. And we're going to multiply these by 100. And we'll end up with 45 over 15 again, which is again going to equal 3. On I, we got 14 4/10, 1 2/10, and we're going to multiply by 10 to get rid of the decimal, and it's going to be 144 divided by 12, and I know 12 times 12 is 144. On J, 1 44/100 and 12/100, multiply by 100, and I end up 144 over 12, which once again is 12. 2. Leanne says 18 divided by 6 equals 3, so 1 8/10 divided by 6/10 equals 3/10, and 18/100 divided by 6/100 equals 3/100. Is Leanne correct? Explain how to solve the division problems. Okay, so Leanne is correct. And that's because if I rewrite these, 18 over 6, which is equal to 18 tenths divided by 6 tenths, which is equal to 18 hundredths divided by 6 hundredths. And that's because all of them are going to be equal to 3, because all of these are equivalent fractions. Now, number 3, they did partial forwards. So Denise is making bean bags. She had 6 4/10 pounds of beans. If she makes each bean bag out of 8/10 pounds, how many bean bags should we be able to make? And you can see she took 6 4/10 pounds, divided them by 8/10. Okay, and you can see down here where she multiplied by 10 in order to get 64 and 8, and she ended up with 8 pounds per bag. Or 8 bean bags, I mean. Now B, if she decides instead to make mini bean bags that are half as heavy, how many does she make? Well, here they say they're 8/10 of a pound. So half would be 4/10. So now I have 6 4/10 divided by 4/10, which I'm still going to multiply by 10, which gives me 64 divided by 4. And I know 4 will go into 64 18 times. And I'm going to double check that. 18 times 4. 8 times 4 is 32. Oh, look at there. That's 72, so it can't be 18. So let's try 17 times 4. That'd be 1428 and 68. Uh-oh. So let's try 16 times 4. Now 6 times 4 is 24. That'd be 4 and 6, 64. So we got to revise our answer, and our answer is actually 16. See, if we wouldn't have double checked it, I would have got it wrong. 4. A restaurant's small salt shakers contain 6/10 ounces of salt. Its large shakers hold twice as much. The shakers are filled from the container that has 18.6 ounces of salt. If 8 large shakers are filled, how many small shakers can be filled? Well, let's see. I'm going to draw a tape diagram so I can see what I'm doing. And I know it says that, according to this, it has 18.6 ounces. Should I get my decimal in there? Now, it says that we have large, and then we have small shakers. Now, if I look at this, it says 8 shakers were filled. Okay. A restaurant's small shakers contain 6.6 ounces. So I'm going to put over here that each one of these has 0.6 ounces. The large shaker is twice as much. So I know the large ones are going to be 1.2 ounce. Now it says here if 8 are filled. So I know I'm going to have to multiply this times 8. So 1 2/10 times 8. Now I know this would, if I did an estimate, this is close to 1 and 8, so it'd be 8. So 8 times 2 is 16. Carry 1. 8 times 1 is 8, and 1 is 9. Okay. Now, in order to put my decimal back in, I know my estimation was 8, so I know it has to be 9.6 ounces. So I know that the large ones took 9.6 ounces. And that was for this much. Now, we started with 18.6 ounces. So I'm going to take 9.6 ounces away, and we will end up with 9 ounces. So I know that the small shakers are full 9 ounces. Now the question though wants to know how many small shakers. Well, if I know 9 ounces divided by 6/10 because there's 6/10 in each small one. And I'm going to have to multiply them by 10. I get 90 over 6. Okay, so let's do a long division here. I have 90 divided by 6. 6 will go into 9 one time. 1 times 6 is 6. And I have a 3. Bring down to 0. 6 will go into 30. 5 times. 5 times 6 will be 30 with no remainder. So now I know that they would actually had 15 small shakers.